assuming you've had a go at the question, let's have a look now. So the first thing to do is to draw a good force diagram. A woman travels in a lift. The mass of the woman is 50 kilograms. So that's sort of a weight. That's a downwards force of 50 G. The mass of the lift is 950. So the lift itself is 950 G. The lift is being raised vertically by a vertical cable, which is attached to the top of the lift. This sounds like a force, so let's call this sort of like a tension force, because there must be some sort of force pulling the lift up. Why? Well, if the woman's there and the lift has a weight as well, what's to stop the thing just falling to the ground? It doesn't make any sense unless there is some kind of tension force here. I'm also going to have to choose a direction for this question, which is not obvious either. The lift is being raised vertically. Well, that gives me the idea that this is the positive direction. So that's what I'm going to stick to. The lift is moved upwards and has a constant deceleration of 2 meters per second squared. So although the lift is moving up, that doesn't mean that the acceleration is acting upwards. It's moving up is about the velocity, it's about the speed of the lift. Okay, so although this direction here might be positive, my acceleration value, because it says constant deceleration, my acceleration value is going to be -2. Okay, what does that mean? It means it's going up, but it's going up more and more slowly. Think about a lift going up and then comfortably coming to a stop. The speed, the velocity there is going up, is positive. However, the acceleration could still be negative at the same time. By modeling the cable as light and inextensible, you'll see this phrase here all the time. What does it mean? Think about from before. No mass, okay, and acceleration is the same throughout. So what's the tension? Well, tension is a force. So I've got lots of forces here. I've got an acceleration, I've got masses. I'm going to try to use F equals ma. Resultant force. What's the resultant force? Well, my driving force is the tension, and what holds it back is 950 G, and then also 50 G. If you prefer, you could write that as T minus 1000 G. It's equal to ma. So it's equal to the mass, and here I'm going to be looking at the whole system, okay? I'm looking at all of the forces, so I'm going to look at all of the mass. All of the mass is 1000. 1000 A. Okay, so T minus 1000 G equals 1000 A. Whoops, and I do actually know what A is, don't I? So that could be times -2. So let's change all of that to -2000. So final answer is the tension will be -2000 plus 1000 G. So that's going to be what, 7,800? Should we double check? Okay, 7,800 newtons. The magnitude of the force exerted on the woman by the floor of the lift. Okay, a bit more difficult this one. So what are we really looking at? The magnitude of the force exerted on the woman by the floor. So what's the floor doing to the woman? Well, the floor is doing to the woman what the woman is doing to the floor. Why? Because these forces need to be equal. Otherwise, the woman will start to float away, or she will start to sink into the floor. Neither thing sounds realistic. So if we talk about the woman and the floor, let's have a think about this. So I'm going to actually stop drawing it like this and start drawing it like a block. It's easier for me to sort of think about. So the woman here is a particle, and the magnitude of the force exerted on the woman by the floor on the lift. So the woman, what force does she have? So she has 50 G downwards because that's her weight. And then there is a reaction force. Okay, there's a reaction force from the lift. What else is going on here? Well, we've also still got the acceleration from the previous part of the question. So I can turn this into an F equals ma. R minus 50g, so my leading force minus my 50g, because I've got the same direction from before, must be equal to 50a. A is still minus 2, because it's the same acceleration from before. Now the R and the 50g, you might be surprised here, it's not going to be exactly the same, okay? And that's because of the acceleration going upwards. If we rearrange though, we get R equals minus 100 plus 50g, which is going to be, what's that going to be about? It's going to be about 380, something like that. So our reaction should be 380 or 390. Okay, so both of these statements here are F equals ma. F equals ma. Quite challenging, I'll give you. Okay, that second one there. But by picking a dominant direction, choosing a leading force, F equals ma, you can solve both of those ones there. This is sort of talking about looking at the system, so thinking about the big picture, and then thinking about one part of it, one particle, or in this case, the woman in the lift that we're talking about. Okay, that should allow you to do sort of the first part of 10E.